Hello and welcome back to Data Center Insights. I'm your host, Emma, and if you've been following the podcast, you know we love digging into what keeps data centers running. But today, we're talking about what keeps them running safely when the pressure's on. Because let's face it, in the AI era, more power means more performance, and a whole lot more risk. We're entering a new phase of data center design. Workloads are exploding. The energy demands of AI are rising faster than anyone projected. The International Energy Agency now estimates that global electricity consumption from data centers could nearly double by 2030, reaching 945 terawatt hours. That's more than the annual usage of some countries. And AI is the big reason. It's exciting from a compute perspective, but for power infrastructure teams, it's a serious engineering challenge, especially when safety, uptime, scalability, and critically sustainability are on the line. So today, let's unpack what modern power distribution looks like in high-density environments, and how we can reduce risks like arc flash while scaling up for tomorrow's needs. So where does all that power go? It's not just about cooling as servers getting hotter. We're also seeing rack densities hitting 80 kilowatts, and with chips like NVIDIA's GB200, even 120 kilowatt per rack. While 1 megawatt per rack concepts appear in industry roadmaps, real-world deployments today are concentrated around 40 to 120 kilowatt per rack. That's a massive leap, and it brings new design, safety, and distribution challenges. Traditionally, AC power flows from the grid and generators to MV switchgear through MV-LV transformers, into the main LV switchboard, then through the UPS to the critical AB distribution boards, onto overhead busway or room PDUs, RPPs, then rack PDUs, and finally, your server racks. That's a long journey, and every step introduces potential failure points, which is why modern design thinking is crucial, not just to reduce downtime, but to protect the people maintaining those systems. Let's take a moment to talk about arc flash events. Arc flash events are among the most dangerous electrical hazards in a data center. Arc flash occurs when a high amperage fault current arcs through air, either from one conductor to another or to ground. When this happens, it releases extreme heat and pressure. It's so hot that it easily melts metal and ignites fires. You can see why it's so dangerous and how it can easily threaten lives. And with higher power densities, the risk of arc flash goes up fast. So how do you reduce that risk? The first thing we can take a look at is an overhead busway system. Unlike traditional cabling, overhead track busways like Starline keep distribution visible, accessible, and often de-energized during plug-in operations. With overhead track busways, the busway remains energized, but plug-in units have local disconnects and must be off before insertion and removal, so work is done with the unit de-energized, reducing exposure. That means you can safely disconnect power before working, dramatically lowering arc flash and shock risks. However, to make safety proactive, not reactive, you will need real-time visibility. That means live temperature and energy monitoring, for example, with the Starline M70 critical power monitor, plus IR window scanning at end feeds to detect hotspots before they become hazards. Bonus, you also eliminate all that messy underfloor cabling that blocks airflow and adds thermal stress. Next up, current limiting protection. Whether you're using current limiting fuses or MCBs, these components are designed to clear faults fast, keeping incident energy low. And when combined with proper selectivity, only the nearest device trips. That means the fault stays local and the rest of the row stays online. Now let's talk a bit about design. Starline track busway is built from the ground up to reduce arc flash and shock exposure. Breakers are enclosed in plug-in units or upstream. The open track channel limits access, and closure strips can cover unused sections. And importantly, it eliminates tasks on or near live parts that are still common with remote power panels. But there's an additional safety layer, the Remote Plug-in Actuator, or RPA. This innovation takes Starline's inherent safety even further. It allows technicians to insert, engage, or disengage plug-in units from outside the incident energy boundary using Bluetooth or a fiber optic link. So what does this all mean in practice? You can plug or unplug power modules remotely, staying on the safe side of the boundary and often avoiding the need for heavy personal protective equipment, PPE, depending on your site's risk assessment. It's a game changer for both safety and speed, streamlining maintenance without compromising protection. Of course, when live work really is necessary, don't rely on broad PPE categories. Base your protection on a site-specific incident energy analysis, so your team wears the right level of equipment, no more, no less. And keep that analysis up to date. Review it regularly, and especially after changes to your electrical layout, like new racks, adjusted protection settings, or altered distribution paths. Update your labels and procedures to match what's actually installed. It's good practice, and in many regions, it's also what regulators and insurers expect. But safety is only half the story. The other half? Scalability. Modern power design has to be flexible, not fixed. That means using modular UPS systems, overhead busways, and scalable LV distribution switchboards that grows with your demand. You don't need to overbuild from day one. You can scale up as you go. With AI workloads expanding faster than expected, modularity is the only way to stay agile without sacrificing uptime or safety. And yes, beyond safety and monitoring, there's a sustainability benefit too. Pair distribution best practices with a high-efficiency modular UPS, such as Legrand Keor Flex to cut waste heat and cooling demand at scale, lowering energy use and emissions and making ESG alignment easier. So, what's the big takeaway? In today's data centers, power strategy is make or break. It's not just about keeping the lights on, it's about doing it safely, efficiently, and in a way that scales. And the good news, the technology is already here, such as overhead busways, remote plug-in actuator tools, fast-acting protection systems, smart monitoring, ultra-high efficient modular UPS, and of course, best-in-class arc flash mitigation. Whether you're building new or upgrading old, investing in safer, smarter power isn't optional, it's essential. That's it for this episode of Data Center Insights. If this gave you a new perspective on powering the AI era safely and sustainably, don't forget to check out our past episodes on UPS design and efficiency strategies. Until next time, stay safe, stay scalable, and keep your data centers running smoothly.